All right, and we are coming toward the end of our unit on parallel and perpendicular lines. And so what we're going to study today and talk about today is going in reverse. So everything we've done so far with the geometric interpretation of parallel lines is if we have parallel lines, what relations do we have? So now what we're going to look at today is standard 7.3. I can determine if lines intersected by transversals are parallel, including finding appropriate measures of angles to ensure the lines are parallel. So basically, we're going to work in reverse and say, what type of information do I need in order to say the lines are parallel? All right, so now to get that, what I would like you to do is do the opener here. So you're going to have to, all right, copy this into your browser. All right, little activity here in GeoGebra. All right, and just follow the directions there at the bottom. So you may have to scroll down. The directions are below the picture in the diagram there. And you have to drag some points around to try to get those lines parallel. All right, and then write down your little summary here about, all right, what you think, and then flip it back on and we'll see what thoughts you have. All right, so I have the GeoGebra activity open here, so let me just pull that up here. All right, so and what I did was I just slid point, all right, A around until my two lines are parallel. And now once again, going back to what we did at the beginning of the unit, all right, how do we know two lines are parallel? And that's if they have the same slope. So if I get AB, the slope of AB here to be, maybe, there it is, 0.19. And the slope of HG is 0.19, therefore we know those two lines are parallel. Now, here's hopefully what you saw, and it's not quite exact, but this angle, FBE, is 47.7. All right, the angle DCB here is 47.4. So they're pretty much equal. So this might be like 0.192, this might be like 0.194, something like that. But hopefully what you were seeing is to get these lines parallel, these angles, all right, have to match, right? And so those same angle relationships that we saw before had to be true in order for the lines to be parallel. So what we learned before is if two lines were parallel, then the corresponding angles were congruent. Well, the converse to that also applies. If the corresponding angles are congruent, then the lines are parallel. All right, and the same thing for all three of the other relationships we saw, right? If lines are parallel, the alternate interior angles have to be congruent. If alternate interior angles are congruent, the lines have to be parallel. Same is true for exterior angles, all right? If exterior angles are congruent, then the lines have to be parallel. If same side interior angles are supplementary, the lines have to be parallel, and on and on. So that was hopefully what you saw in, all right, in the opener here. So now let's go ahead and summarize some of the thoughts that I just had with you, all right, down here in our diagram. So if corresponding angles are, all right, congruent, right, then the lines are parallel. All right, and so, right, so we know angles 1 and 3, okay, all right, are corresponding. Now, if I know 1 and 3 are congruent, right, so if I know 1 and 3 are congruent, then I know the two lines that they are corresponding to are also parallel. If alternate interior angles are congruent, then the lines are parallel as well. So once again, we know 2 and 7 are alternate interior. If 2 and 7 are congruent, that means the two lines that they are alternate interior to are also parallel. If same side angles are supplementary, then the lines are parallel, right? So 2 and 3 are same side. If we know 2 and 3 are supplementary, they add to be 180 degrees, we know that the two lines are parallel. All right, so that's page 59. So let's flip over, all right, and then go through two more sets of relationships here. All right, if alternate exterior angles are congruent, then the lines are parallel. So once again, we know 5 and 4 are alternate and exterior. As soon as we know 5 and 4 are congruent, all right, then we know that the two lines that they're alternate and exterior to are also parallel. And finally, if same side exterior angles are supplementary, then the lines are parallel. And so once again, let's say 1 and 4 this time. As soon as we know 1 and 4 are supplementary, we know the two lines are parallel. All right, so really, if you know the relationships, it works in both directions, right? So if lines are parallel, corresponding angles are congruent. All right, and then we can reverse that. If corresponding angles are congruent, then the lines are parallel. And so that works for all sets of our angles. All right, so now let's look at some specific examples here. All right, so let's look at number 1 here. And notice we want to state the value of angle that will make line U parallel to line V. So when I look, here's line U, here's line V. I have 126 degrees for this angle, and then I have this angle here. So the first thing we want to identify is what type of angles do we have? All right, and those would be alternate interior. And then for the lines to be parallel, we want alternate interior angles to be congruent. So if this is 126, then our mystery angle here also has to be 126 degrees. And then that makes our two lines parallel. All right, so this has to be 126 degrees as well. All right, so moving on to number 2. All right, so we were talking about these two angles. Okay, so once again, what kind of angles do we have? They are corresponding. And we want corresponding angles to be congruent. So these two angles both need to be 100 degrees in order for U and V to be parallel. So that would be that angle. All right, let's just move down to 3 here and 4. All right, so now when we look at these two angles, right, these two angles are same side interior angles. Now remember, we want same side interior angles to be supplementary in order for our lines to be parallel. So if this is 92, all right, then we want this to be 88 degrees. So that 88 and 92, all right, that's 180, all right, and therefore our lines U and V will now be parallel. All right, and lastly here on number 4, we have these two angles, and these two angles are alternate exterior angles. All right, we want alternate exterior angles to be congruent in order for our lines to be parallel. So we want those two angles to both be 105. Therefore, those two angles are going to, or excuse me, those two lines will be parallel. All right, so that takes care of that page. So let's do a few more examples here together. So let's look at page 61 here, and let's look at problem 5. All right, so now what we're going to do is say, okay, find the value of x that makes the lines parallel. So it's really the same process that we just did, all right, as far as establishing the relationship, but then we have to write the equation and actually do some solving. So once again, if we look at this problem, notice we have alternate exterior angles, all right, in the same way. We just had alternate exterior angles here. And so for our lines to be parallel, we want those two alternate exterior angles to be equal or congruent. So I want this angle to be equal to this angle. So that means I want 7x minus 3 to equal to 6x plus 6. All right, I'm going to go ahead and make the right side equal to 0. Subtract 6x from both sides. Subtract 6 from both sides. That's equal to 0. 7x minus 6 is 1x. Negative 3 minus 6 is negative 9. Okay, and then what minus 9 is 0? That would be 9. So x equals to 9. Now, once again, we should test this just to be sure, all right, that it's worked and that our math is good. All right, so if I take 9 and plug it in here, all right, so 7 times 9 is 63. And then 63 minus 3, this says this should be 60 degrees. All right. Now, if I take 9 and plug it in here, 6 times 9 is 54. 54 plus 6 is also 60 degrees. All right. So once we solve for this x value, we really should go back and plug it in and make sure that that relationship that we want actually happens. All right. So what value of x do we want for number 5? We want x to be 9. All right. So let's move to number 6 here. All right, and now we know that now I'll put my parallel lines markings on those two. All right, so if we look at number 6, once again, we start with what kind of angles do we have, and then what relationship do we want. So these are alternate interior angles, and so if we want our lines to be parallel, we want alternate interior angles to be equal. All right, so I want 11x minus 6 to equal to 6 plus 9x. All right, now once again, once I establish that relationship and write my equation, we get into solving. So I'm going to make this equal to 0, subtract 6 from both sides, and then subtract 9x from both sides. All right, so I get 2x minus 12 is equal to 0. All right, and then once again, what minus 12 is 0? 12. So we know 2x has to be 12. Divide by 2, and we know x has to be 6. All right, so now once again, we should go back and test. All right, so 11 times 6 is 66. Minus 6, all right, this is 60 degrees. All right, take 6 and plug it in here. All right, 9 times 6 is 54. 54 plus 6 is 60 as well. So we can see that we do, in fact, get equal angles. Not every angle is going to be 60. I know that's kind of how it worked out here in the first two examples. All right, you should hopefully get some other angle values along the way. All right, so let's try to get through 7 and 8 here. All right, and then that will wrap up our video for today. All right, so now once again, start by establishing what type of angles do we have. Okay, and we have same side interior angles. All right, and then what relationship do we want from those? We want those to be supplementary. All right, so we want 7x plus 11 plus 17x plus 1 to equal to 180 degrees. All right, so we want those angles to be supplementary. So 7x plus 17x is 24x. 11 plus 1 is 12, and that equals to 180 degrees. All right, once again, I'm going to make the right side equal to 0 by subtracting 180. All right, so 24x minus 168 is equal to 0. And then once again, we do this because we should know that opposites give me 0. All right, so 24x should equal to 168. All right, and then we should go ahead and divide by 24 to get our value for x. And if you do that, you hopefully get x is equal to 7. All right, so now if we take that and plug it back in, right? So 7 times 7 is 49. All right, 49 plus 11 is 60. All right, so we're setting a bad precedent here. So it looks like everything's going to be 60. All right, that's not really how it works. So hopefully this does it, because we know this has to be 180 here. So let's do 17 times 7. All right, I'm just going to use my calculator to verify that. All right, so that's 119. 119 plus 1 is 120. All right, so they do in fact add to be 180. So we know they are supplementary. So we definitely want x to be 7 for lines U and V to be parallel. All right, so one more problem here to wrap up our video. So once again, let's start by asking ourselves, what kind of angles do we have? All right, they are corresponding. What type of relationship do we want corresponding angles to have? We want them to be congruent, all right, or equal. So negative 11 plus 10x, we want to be equal to 99. All right, we know for sure we better not get 60 here, or we're going to have some issues, right? It should be 99 once we get our x value. So let's go ahead and get the right side equal to 0 by subtracting 99. So that gives me negative 110 plus 10x is equal to 0. All right, and then negative 110 plus 110 is 0. So 10x has to be 110x, which means x should be 11. All right, so now once again, we already know that this angle should be 99, right, if everything worked out. So if I do, all right, 110, all right, times 11, I get 110. And then if I subtract 11, I get, in fact, 99. All right, and so that means that we definitely want x equals 11 if we want these two lines to be parallel. All right, that wraps up our lesson on how to determine if lines are parallel. All right, have those notes ready, and I will see you in class next time.